Is it working? Yep. I've got the unfortunate subject of water because it's quite unsexy. So it's quite a challenge for me, here in Malta especially, to get people emotional about something which they cannot empathize with. It's not like saving whales. It's saving water. In the case of Malta, it's all underground. So it's invisible, out of sight, out of mind. It's so precious that we need water. I mean, people die if they don't drink water in a week. We can live for months without food. But we need to drink regularly because it's essential for life. And yet we take it so for granted. We take it so for granted that, for example, I see lots of cups of coffee on the table. But really few people know that for each cup of coffee, there's 140 liters used in the production of 1 cup of coffee. So somewhere in the world, to make the coffee beans, to make the sugar, to actually process the same coffee, 140 liters, which is like anywhere between 10 and 12 buckets full of water, has been used somewhere to provide us with 1 cup of coffee. So this is the relevance of water. About 2 weeks ago, the population of the world hit about 7 billion people. This graph is actually in a logarithmic scale. So if I had put it in a linear scale, it would actually shoot up about 20 stories up. And this is the way it's increasing. And parallel with this, of course, the water demand is increasing in a similar fashion. Probably more, because with our increasing standard of living, we are now consuming more water per capita than ever before. How much water is there in the world? Well, if you see this chart, actually fresh water is only 2.5% of the total. And out of that 2.5%, what is actually accessible to people is just lakes and rivers, which is 0.3% of the 2.5%. So even when it rains, even here in Malta, and we see all these floods, that's really a minuscule amount of water. The real water is actually in the sea, but the bulk of the water, fresh water, is actually under the ground. But to get water from under the ground, it's got to be accessible. I mean, I was in Ethiopia in August, and probably all know about the drought in the Horn of Africa, which has hit Somalia. People are dying out of thirst, but they're actually standing on water. The only problem is they don't have access to it. When I was preparing this presentation yesterday, I decided to make a quick calculation from the 2 previous slides. So the amount of water available divided the population, how much is it on a per capita basis? And it's actually about 1.5 million cubic meters per person. Now, 1 cubic meter is 1,000 liters. So that's a lot of water, which essentially, theoretically, is 47,000 years for a population of 7 billion people. That's a lot of water. But it's a very simplistic way of looking at things because, of course, population will continue to increase, so that amount of water has to be shared among more and more people. There isn't an equal distribution of water among the world. Like I said before, you need to have access to water. I mean, water in ice, in glaciers, really isn't very useful unless you've got a hell of a lot of energy to actually melt it. And the big problem of pollution. I mean, as people who have invented chemicals, where 1 gram of chemical would contaminate literally billions of liters of water. This is distribution of water in the world. The blue areas, of course, desert regions. The red areas are areas which enjoy some certain amount of water, but because of population increases, the water is under stress, which means it is getting increasingly harder to provide the population with their water requirements. But if we look at where the bigger cities are, it seems that we've got very big cities, very high populations in areas where there is no water. If we go back throughout centuries, the biggest civilizations have always existed close to water. I mean, Romans from the Tiber, Egyptians on the Nile, and so on and so forth. because it was only logical to do that. Now, because of the use of technology, we're actually living in places which are not really habitable because there's no water, which isn't very sustainable, is it? I mean, this is a golf course in Arizona. Okay, technology makes it possible to get certain amount of water over there. But essentially, I was discussing this with a colleague yesterday. You know, America is getting its water from Canada. So this is the water cycle, water management cycle in the developed world, and this is what we're trying to promote even to the developing world. So there is a source of water somewhere, lake, river, sea. We are investing in technology to produce potable water, and I must make this point. In all the developing countries, you generally tend to have one supply of water, which is potable water, which is a high value of water. In that process of taking the water from the producer to the consumer, there are losses, apart from the fact that you are using energy and fossil fuels and consequently carbon dioxide emissions to get it to the consumer. The consumer uses the water once. It becomes wastewater. It becomes a problem. And you've got to get rid of the problem. Traditionally, we've just dumped it into the seas or into the rivers, causing pollution, which then affects the source of the water. So there's less and less water every day. In more affluent countries or in the more environmental aware countries, you've got sewage treatment plants. But this requires, of course, energy. And getting even sewage from the consumer to the sewage treatment plant, there's a whole infrastructure there. And this infrastructure leaks. I mean, I think in the case of Malta, more than 50% of the sewage doesn't even get to the sewage treatment plant, because there is an objective to make sure that the potable water supply doesn't leak, because there's a value to it, but really, there's no value to sewage, because it's a problem. And my presentation will focus on how to try to break this down into something which is more sustainable. And I've come up with solutions which actually break this down into something which is more sustainable and tries to get away from this, say, conventional modern situation. Well, I mentioned that we only get one supply of water in our taps, in our homes, one source of water. And it is potable water. I mean, even Malta, as part of the EU, we are supplied with a quality of water which meets EU drinking water standards. But if you see how we use water in our homes, only 3% of that water is actually used for potable purposes. 97% is used for other uses, mainly secondary uses, flushing of toilets, showers, gardening, washing the car. Why does that water have to be potable? So why are we supplying 100% high-quality water and losing 40% in the process of getting it to the consumer, when it's actually, we don't really need that quality? In fact, a questionnaire among Maltese consumers shows that even though the tap water is certified potable water, it's about 10% of the population actually drink that water. So we are making all this effort getting this high-quality water to the consumer, but it's not even being appreciated. People prefer to buy bottled water for whatever reasons. So I'm going to bring the discussion back into context here in Malta. This picture shows the availability of water in European countries. And if you look at the legend, Europe considers countries having less than 2,000 cubic meters of water per capita per year as countries with very low water resources. So, and that even includes Germany and Poland. But if we look at the figure for Malta, it's 58. So, in a European context, any country having less than 2,000 has a water problem, and we've got 58. So our starting position is 2.5% of what Europe considers to be a low amount of water, which, of course, means we are in an extreme situation. But are we really living as if we are in an extreme situation? Are we actually trying to solve the problem? Are we indeed aware? In Malta's situation, we don't have lakes and rivers, so our starting point is the sea, which means we need to produce water by desalination, reverse osmosis process, which is a high consumer of electricity. But have we, despite investments in reverse osmosis plants and sewage treatment, have we really got control? Are we in control of the problem? This is a situation which happens regularly, I would say almost every time it rains. And we're actually investing in infrastructure to get rid of rainwater when it's raining, and exactly at the same second, we are pumping water from the sea, treating it to potable water, and pumping it inland. So I think it's about time somebody tries to, connect the two things together. Is it possible to get rid of one of the arrows, which means the supply side, even at households? And this is what I've worked with the last 7 years. We've got to start reappreciating rainwater. I mean, the population of this country has existed because we have traditionally, over centuries, really appreciated rainwater. Few people know, but we've got the oldest surviving rainwater harvesting systems in the world, in between the two prehistoric temples of Imnaidra and Hajar-Im. But few people know this. But these guys were smart. Before building temples, they actually invested in water to ensure that they will survive, the next summer. So we've got this substantial amount of clean water falling literally on our heads and on our roofs. What I've done is when I converted my 400-year-old house about 7 years ago, being a water engineer, I said, okay, can I design this house to make it completely self-sufficient in water use? Of course, the starting point must be rainwater. But unfortunately, in Malta, it's not so easy because we've got limited amount of rainfall. And moreover, it's available in winter, not in summer. So you need some storage capacity. And even if you have a cistern, it's not enough to see you all through. So I had to really put in some other things. One of the things is gray water recycling, which means the wastewater from showers and wash hand basins could be treated and then used for the flushing of toilets. So I don't use rainwater for actually flushing of toilets. And this is the result. So the red line shows what the average consumption for a typical Maltese citizen is. This is our household consumption. It's been a bad year in August in terms of rainfall, so at some stage I had to get in some town water supply. But 95% sufficiency in water is I think, an achievement. I've used this idea in Sri Lanka. I mean, Sri Lanka, post-tsunami, a lot of houses were built without any water supplies. I've seen brand new houses, nobody living in them because no water supplies. But it's raining, and they're getting rid of the water, so the solution was put in a tank and you're sorted. Problem is Malta. Whenever it rains, we don't have the infrastructure. A lot of houses have been built without cisterns. Sewage system overflows. So it's a whole mess. One of ideas I came up with 2 years ago was, why don't we channel that water falling on our roofs into the ground? Because our aquifers are being depleted by boreholes. Why can't we put that water into the ground? It's clean water. So I turned around the concept of boreholes by drilling boreholes with the intention of putting in water which falls on the roof back into the ground. And this is a project which is up and running together. There's research going on, but it's really working fine. Hotel, big consumers of water, same situation. A project I started work in 2006 was, is it possible to get a situation whereby a hotel becomes self-sufficient? Of course, there's not enough rainfall to make it self-sufficient, but there is a source of water being discharged from the hotel, which is plentiful. It's almost equivalent in terms of volume as to what the hotel is using. And this is, of course, sewage. And if you see that sewage is 99.99% pure water, all you need to do is remove the 0.01% impurities, and you've got pure water. So my solution was put in a treatment plant, which takes the sewage from the hotel, treats it in 2 stages. The first stage would be for the flushing of toilets and landscaping, because it's certain quality of water. With the surplus of the water, treat it further, get it to potable water standards, and send it back to the showers. And I had a prototype running for about a year. This is me checking the operations of the plant. This is the process. So sewage into second-class water used for flushing of toilets, drinking water, certified by the public health authorities. I've drunk it regularly. A few months after I stopped the project, I actually climbed Everest. So if there are any nutrients in that water, they're actually beneficial. This brings me to the end of my presentation. What I'd like to say in conclusion is that innovation is a buzzword. But I really don't believe that you can teach innovation. Innovation comes from a need. We have to feel the need. And I think when it comes to water, there's no bigger need than in Malta, which really drives me to come up with solutions. Thank you very much.